For this lab, we're going to be running a titration. A titration is when we have an unknown molarity of an acid or a base, and then we add the opposite. We reach a neutralization point, and then we can use those amounts to determine our final molarity of what we were missing. In this case, we have an unknown molarity of HCl. So we don't know what the concentration of that is. You'll see here we also have phenolphthalein indicator and a 10 milliliter graduated cylinder. This is a beaker down here. You can also use a flask, but we don't really need very much for this lab, so we're going to use a 50 milliliter beaker. And then this apparatus is called a burette. And a burette measures a liquid. The way a burette works is that it measures backwards. So you can see here the top of the burette is reading 0, while the bottom of the burette is reading 50. So right now, if I were to read the top of this burette, I would make sure I want to read to the bottom of that meniscus. You want to read 1 decimal past the precision of that instrument. So I'm seeing it at about 2.335 or 2.37. All right, so that's what we're going to write down. It feels weird because there is a lot more than 2 milliliters in there, but you'll have to trust me that this is how this works. So the first step is going to be adding a known amount of hydrochloric acid. So we're going to pour the hydrochloric acid into our graduated cylinder. Okay, it looks like I kind of overshot it there. Trying to do it while I take a video is not easy. All right, you're going to add a known amount there. So in this case, I want you to go near 10 milliliters, but you don't have to be exact. All right, so again, read that to the bottom of the meniscus. I'll give you a minute to write that down. Okay, then we are going to add this into our beaker. Okay, the next step, and a lot of people forget this, don't forget the phenolphthalein, all right? All you need is really 1 or 2 drops of phenolphthalein into there. Now, you'll notice nothing happened, and that's because the phenolphthalein is clear when it's in an acid. And we know here that we have hydrochloric acid and it is clear. So we are going to now run through a titration. These are kind of hard to see. So what I like to suggest is grabbing a piece of white paper, and really any white paper will do, so that you can see the color change a little bit better. So here's another value you need to write down. Okay, so this is the reading on the burette. That's the initial reading on the burette. Make sure you write that down, reading to the bottom of the meniscus. And then we are going to start adding. Oh, I forgot to mention, we are going to be adding a known concentration of sodium hydroxide. The concentration of this sodium hydroxide is known. It is 0.1 molar. That is our concentration in here right now. I know that this is 0.1 molar. I don't know what this is, but I know that I have 0.1 molar sodium hydroxide. All right, let's go ahead and start adding. You can kind of go quickly at first, but you'll notice it starts to, maybe you start to see some pink color. See the pink? It's going in there and then it's disappearing. All right, it's staying a little bit longer with each time. I got it kind of wet under there. Rinsed my beaker beforehand. So as I release, this is called the stopcock, as I release, I can see that color is persisting for just a second. What we're looking for is that pink to be very, very faint. Okay, so when you start getting to where the color is staying for longer than a second, you want to start slowing down this titration because you do not want to overshoot your endpoint. Where the endpoint is going to be is where we have these equivalents, sometimes called the equivalence point. So sometimes people will overshoot this. You have to be very, very, very careful at the end. And you can pick it up and swirl it to go drip, drip, drip. And there you go. That's pretty good. It's a very, very, very faint pink. I probably went a little bit too far, but holding this and doing it has proven to be quite a challenge. So you would even want it less pink than that in an ideal world, okay? You'll get a feel for it, but we have now reached what we call the end point or the equivalence point. So how much NaOH did we add? Well, you remember the burette reads backwards, right? So we're gonna go back up our burette, and we remember that we started up here. Well, now this is our final reading. Give you a minute to read that. Write that down. And what you'll need to do is take that initial reading and subtract it from the final reading. That will give you the amount of NaOH that you added to this hydrochloric acid. We reached our equivalence point, so we are going to use our sodium hydroxide.